So let's go on to objective 3, which is determine the amplitude and period of sinusoidal functions. So the number a, when you have y equals a sine omega x or y equals a cosine omega x, tells us that if the sine of x is always between 1 and -1, and then I multiply everything in this compound inequality by a, then we can see that a sine x must be stuck in between -a and a. So another way of writing this compound inequality, maybe you remember this, is that a sine x in absolute value is less than or equal to a, so that we know that the graph goes up to a now and down to -a, and a is called the amplitude. It's absolute value because if we have y equals -2 sine of 3x, this negative is a reflection and not part of the amplitude. So the period of the functions y equals sine omega x and y equals cosine omega x is 2 pi divided by omega. So this is a formula you need to know. 2 pi is the basic period, and then the omega multiplier changes the period. So the amplitude changes the height of the waves, but doesn't move the zeros. And changing omega changes the period. So the function y equals sine 3x will have a period of, let's see, t equals 2 pi over the omega, which is 3. So the graph will make one complete cycle in the interval from 0 to 2 pi over 3. So it's squashed up because we multiplied by 3, so it compressed the graph horizontally. And the graph y equals cosine x over 2 will have a period of t equals 2 pi over 1/2, which is 2 pi times 2, or 4 pi. So it'll have a period of 4 pi. So it will make one complete cycle as x goes from 0 to 4 pi. So multiplying by 1/2, which is between 0 and 1, does a horizontal stretch of the graph. Okay, so objective 4 is to graph sinusoidal functions using key points. So we talked earlier about the basic sine graph having zeros, a max, and a min. So those are your key points always. And notice that this is the period, whatever it is, 2 pi in the basic graph, but it can be different as we just learned. Whatever the period is, it's evenly divided to this point is t over 2 from the beginning. And then the end is t over 2. So this 0 comes exactly in the middle. And this max comes exactly in the middle of that interval. So we're going to divide the period, whatever it is, into 4 equal pieces. And this pattern will always hold for the sine graph, that it's a 0, then a max, then a 0, then a min, then a 0, unless you have a reflection. So another way of graphing is using this way, and you use key points for, we call the zeros, maximums, and minimums, the key points. So notice that the sine graph will start at 0, 0. It will increase to a max, then decrease to a 0, keep decreasing to a minimum, and then increase back to 0. So now let's look at the cosine graph, and we'll analyze it in the same sort of way. So we're going to draw some graphs in class, and here are our examples to work on. And objective 5 is to find an equation for a sinusoidal graph. So this is kind of working in the opposite direction, looking at a picture and deciding what is the equation of this graph. So here's the things to look at first. Decide whether it looks more like a sine graph, where y equals sine x. You should be able to do this quickly. And say, let's see, the sine graph starts at 0, then increases, and so on. Then the cosine graph starts at the max, at 1, and decreases into a min, and then increases. So this graph, number 72, to me looks more like the sine graph, because it starts at 0 and it increases. So y equals sine x would be the basic graph. But then we see that the top is 4. So we say, oh, so that means it must be y equals 4 sine x, because that's how you get the waves to be taller. And then we say, how long does it take until we get through one cycle? 2, 4, 6, 8 pi. So the period t is 8 pi. Well, this equals 2 pi over omega. So I want to solve for my omega. So 8 pi equals 2 pi over omega. Multiply both sides by omega. So I have 8 pi omega equals 2 pi. Divide both sides by pi and see that omega equals 1/4. So my answer is y equals 4 sine x over 4. So the period got way bigger because I multiplied by a number between 0 and 1. So that's how we're going to analyze these graphs. And that's all we have in section 2.6.